Hi everyone. Today we're gonna be talking about this problem 3504, longest palindrome after substring concatenation. I'll just quickly go over the idea of the problem and like how we can try to solve it and why this is a hard problem. So there's a brute force way to solve this, which won't require all this processing, which we're gonna do now. But because of the constraints, we're gonna have to try out a different method from apart from the brute force. So let's look at the statement. You're given two strings, S and T. You can create a new string by selecting a substring from S, possibly empty, and a substring from T, possibly empty, then concatenating them in order. Return the length or the longest palindrome that can be formed this way. So looking at the sample test cases, we have S, A, and T, A. So the output is 2 because we can just concatenate them whole, A plus A. So that'll be a palindrome. Now in A, B, C, and D, E, F. So if you see, all of them are different. So we can't like even take two from one string because they're not the same characters, right? So it won't be a palindrome. So the output here is 1. Given this, the output, the S is B and T is 4 times A. So we'll just take the entire T string. Uh, these are not very informative test cases, but this one is quite close. So S is A, B, C, D, E. T is E, C, D, B, A, right? So we have output as 5. So how can we generate that? We'll take A, B from this string, A, B, C from this string, and B, A from this string. So when you concatenate them, first character and last character is A. Second and second last will be B, and then C. Odd length. So this does not, the C does not have to match with anything else. You could also take this string and this string. So A, B, D, B, A. Does not matter. So you have output of length 5. Now, look at the constraints here. So it's both lengths are between 1 and 1000. So uh, what if you try to brute force this? How would you do it? So you would take two indexes I and j in this, and two indexes k and l in this, right? Two pointers here, two pointers there, and generate each substring and try to see if it's a palindrome, and if it is, try to maximize its length. But that is not a very feasible situation because that'll go to n power 4, right? Because for each I and j that you're selecting in S, you have to select K and L in T. So it's technically four nested for loops. So it's n power 4, which won't be accepted here because if you see the time constraint, this will be somewhere around 10 power 12, which is not ideal. So we have to find a different way. Like just looking at the constraints, we can see we can have a solution which is 10 power, n square, right? So 10 power 6. So if we stay close in that range, we can, looking at the constraints, we can get an idea of what a solution will look like. Okay, so let's try to figure this out. Uh, Give me a second. So we have a string. So let's say S was A, T was A, right? In this case, the length was 4. Now let's take another example, which is S is A, B, C, D, E, F. T was, let's say, was A, B, C, B, A, D, X, right? In this case, what will be the answer? So you can take these four from here, these four from here. When you concatenate them, it'll be A, B, C, D, D, C, B, A. On top of that, length is not 8 because you can take another additional character from either of them, either E or X. So if you take E from string S, this is substring from S, this is from T. This is also a palindrome. So answer would be 9, right? Okay. Now, uh, just because we have to maximize this number, like the immediate solution that comes to my head is dynamic programming, right? So forget about optimizing the DP solution and just think about how you would go about solving this. So if I start a pointer from index 0, right, in this S string, and suppose this was of length m, this was of length n, right? And you'd start a pointer from n minus 1 in this case. Now, if something matches, you would increment that pointer. So this is pos S, this is pos T, right? Position T. So now you would have a bunch of cases. What would the cases look like? So either you start matching it at any position that you're in a recursive solution, you'd start matching it, or you do not start it, right? So we need that information first of all. Like either we have, when we're in some state, so if we're in some state, we need to know if we have started matching or not. So which is the Boolean value. So true or false or 0 or 1. So I'll call start equal to 0, meaning it hasn't, the matching hasn't started. Also, what do we need? We need position of S, where you are in that state in string S, and where you are in that state in string T. So we can see at least these are uh, some of the parameters that we would need in order to even find a solution, right? So now, if start is not 0, that means you haven't started uh, matching those strings, those positions, right? So there can be two cases, right? Uh, let's call this case 1. And from this state, so initially you would call this with the state where start is 0, so you haven't started matching. You're on 0th index on S and n minus 1 index on T, right? So, first of all, why are we doing this? Why are we starting it from the opposite positions? Because you need the concatenated string to be a palindrome. So instead of starting the beginning, from the beginning in T, instead of that, what we're gonna do, uh, we're gonna start from the end and at the same time match these two characters or match these two characters. Otherwise, we would start from this and generate some string here, and then check if it's a palindrome. We don't want to do that. So we're starting at position 0 in S and position n minus 1 in T. Okay. So you start off with this state. This is my state 0, right? Now, when I'm in some state, let's start with thinking what would happen when you haven't started matching where start equal to 0, right? So in this case, there are two cases. So case 1 is you do not start it yet. So start still remains 0, and you move S pointer, increment the S pointer, pause S pointer to one index after it, right? And stay in the same position in T. The other case being you move to a state where you haven't started still, you haven't started matching, you stay in the same position in S and you move in T towards the starting. So remember, in S you're moving this side, in T you're moving this side. Okay, so these are the two cases. Now, uh, are these the only two cases? No, right? Because you could end up in a state where you have started matching. So if, or let's say if these two, there's another case where array of, or sorry, S of position S and T of position P match. So basically in this string, A, B, C, D, E, and D, C, B, A, X. So in the beginning, you were in this state where S was there, pos S was here, pos T was here, and you have entered the case when they did match. So in uh, in this case, you could either start with case one and case two. So you move S to B and let pos T stay at n minus one, or you decrement pos T and stay in same place for S. Also, you could start matching from where you are if these characters match, right? So in this case, case 3 would be 2 plus. So why did we do 2? Because we are saying we have started matching and these two characters match. So at least we have a palindrome of length 2, right? So you would go to, once you matched, you increment pos S and decrement pos T. And you have started, so start becomes 1, right? Plus 1 pos T minus 1. So this is one case, right? Now, what if they do not match? So this was the case where they matched. What if they do not match? So we have considered the case where we haven't started matching, which is this, right? Now, in one of the cases, we're handling if you just start matching or it was already started and the characters match. So you can just increment it. But this condition does not hold. So you have come to a place where, so suppose this was P, right? And after matching A and A, your pauses was at B and this was at T. T pause was here. So when you come to this state, you have started matching and these two characters don't match. So there's another case where we say else if start equal to 1. So you have started, but the characters in both the strings are not matching. So what would happen there? We have covered case 1 where you did not match. You have covered case 2 where you did not match but moved the different pointer. Now there was one case where S pos S pos of S and T pos of T matched. So in that case, you incremented our palindrome. You added 2 and you incremented our palindrome. Now, this is the case where we're trying to optimize the solution. We would need to know something about this string, which is already pre-processed. And in this case, we cannot just return 0. Why can't we do that? So just think about this. This is S and this was T, right? So S was X A B C and T was D E F G G G. Okay, so look at this string. Now in this string, what is the maximum palindrome size that you can get? Is it just X and X? So you concatenate this substring to this substring? No, right? Because there's one additional part in T which can be used to increase the size of our palindrome, which is this. And this is the case where when you entered our state, initially our state, you were here, right? And start was 0. So at some point you said, okay, I'm gonna start my matching because they match. So you entered this part, right? So you match these two, x and x were equal. So your case three answer was 2 plus the state where you're now at A in S and G in T, right? So in this case, what should happen? Should you just return? So this is the case where they do not match. A and G do not match, and you've already started forming our palindrome, and they do not match. So you can't just return zero. You have to return the length of this substring, G, 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 G. So in this case, you should have ideally returned 4, not 0. It could be different for different substrings. So S was X, A, B, C, and this was D, E, F, I, and X. In this case, you should have returned 3 in this case, right? So you now know you have, uh, let me rub this down. So you had a start condition. You're good with this. So you know, like when I've not started, I can either, this is like longest common subsequence. So you decide to move one pointer. You in LCS you have two strings, right? So you either move M or you move N because you can start matching from anywhere, right? So this is a similar case. So you haven't started, so you can either move S forward, pause S forward, or you can move pause T behind, like towards the start of the string. This is a simple case, okay? This we do not need any additional information. For this also, we're quite clear. So if they matched, you can just start matching them. So you increase the size of the longest palindrome that we've gotten till now as 2. And the next state, which is incrementing pauses and decrementing pause t with start 1, saying that when you come to this state, you know you have already started matching. But in this case, where they do not match, you can't just return 0. So this is not a normal base case. Okay, coming to the base case now. This was the recursive formula. We'll come back to this part of the solution later, like how you would handle this. This is the only pre-processing we need in this for this return case and also the base case. So now imagine uh, what the base case would be. So this is my recursive, right? Now for the base case, what is a very simple base case that you can think of? So spos has reached the end of the string. So you can't match anything, right? So basically, if spos equal to m minus 1, m, assuming the length of s was m. So this was of m length. Or uh, tpos has reached minus 1. So this t has been decremented enough times to reach the start of the string, right? So these are our base cases. In this case, again, you cannot return 0. Why is that? So suppose this was our string. This would be wrong. So this was our s, right? This is a very simple string that we can think of, which would mm, give an incorrect answer if you just return a simple 0 in this case. Okay, so this was T. Now you kept going into case 3 again and again when you're matching. So these two match, so your palindrome length became 2. These two match, you incremented S pauses and decremented T pause T, and they again match. So this was 2 plus next state. Next state was this match. So plus 2. Again a match. So plus 2. Now S got incremented and reached M, right? T is somewhere over here. sorry, pos t is somewhere over here at I. Now, if you return 0 from this final state, would that be the correct answer? No, right? Because you're missing some part of pos t which you could have included just from t. Or like inverse case would be A, and then B, and then A was t. So in this case, t reached -1, right? And S was, pos S was here. This was pos t. So in this case, the correct answer won't be 6. 2 plus 2 plus 2. It won't be 6. It'll be 6 plus this length, right? So now we come to the point why these, first of all, this case where you started matching and the present characters did not match, cannot just return 0. Similarly, with the base case, when one of the pointers of both the strings have reached the ending or the beginning, ending in case of S and beginning in case of T, you cannot just return 0. You need to return something else. So what is that something else? Again, so uh, we're getting ahead of ourselves, but just to see what this, like if we memorize this, if we make it, right now it's recursive, right? But in case we do decide to cache it somewhere, the values, this would be of pos s, length m, and pos t, t, O of mn solution, right? So we are still under our limit. As we saw, m and n could be between 10 power 3, right? 1 to 10 power 3. So we still are in 10 power 6 operations, right? So we're good right now. So if we decide to memorize it, we're good right now. But only thing we need to now figure out is what is this return value going to be? And we have to figure it out in again something better than m cross n and not in a higher order. It should stay in m cross n. So for this case, what should we return? Or what should we return when either of the pointers reach the ending or the beginning, respectively, right? So now we know the DB solution. There's just one additional step here. That additional step is finding the length of the longest palindrome in S and T individually for each index. So let's take this string for example again. Okay. So what is the largest palindrome? What I'm going to find now is what is the largest palindrome length of the largest palindrome I can find when the starting index is 0. So these are my index values. So in this case, you can see it should be AAA, or no, sorry, it should be AAA, right? Because starting from here, what is the largest? So 3. For this, 2. For this, 1. For this, it should be 5. For this, it should be 4, 3, 2, 1. Similarly, this is for S. Now for T, what I'm going to find is what is the longest. So if this was T, I'm going to find what is the longest substring, which is the palindrome, ending at certain index. So you have 0, 1, 2, 3, 5, 6, 7. So basically, you're starting from this side and moving towards this side. So in this case, this value is 3. This is 2. This is 1. 5, 4, 3, 2, 1. Now, assuming we have these values, right? So this is, let's call it LPS of SI. right? This is LPS of Ti. So now as we'll get back to how we would find this, but now we have our answer for this problem. Like what should be the return value? So in these cases, the return value, once you stop matching, the return value should be what string. So if suppose, okay, let me just make it a little tidy. So let's go by this case first. So in this case, you should not return 0, but instead, uh, you should return dp of pos or lpst of pos t or t pos, whatever. So this will now we know that VS LPS of T, what it denotes is what is the longest palindromic substring ending at a certain index. So in this case, we calculated it to be 5, right? So 5, this should be 4, 3. So you would know that this like additional string starting from somewhere in T till this position, you could include these many more characters and it still be a palindrome because we know this part is a palindrome. So anything in between is also a palindrome, right? So the maximum length you can achieve at pos t is this. Similarly, if you were in this case, pos t had ended, but pos s was still somewhere in the middle of s, you would return LPS of s pos s, right? Which would give you 5. So I hope this part is clear. So instead of returning 0, we are just checking for a case where there is an additional part of palindrome which could be contained in either of the strings. So well and good. You matched S, you matched T. That's good enough. So you got 4 from S, 4 from T, which were a palindrome when concatenated together. But ending at that index wherever it stopped, there could be an additional string contained in either S or T completely. So this is what LPS of S and T are giving me. They're giving me the longest substring. LPS of S is giving me the longest substring starting at a certain index, and LPS of T is giving me the length of the longest substrings ending at some index in T. So similarly, for this case, you would return uh, maximum of LPS S and LPS or S pause. Sorry for making it very untidy, but you get the idea. T pause. So now we have a complete solution. And finding these arrays in O of n square is uh, a very famous string problem. So you'd start from, so how you would do that? So the idea is when finding LPS in two indexes I and j, how do you know if this is a palindrome? So I and j denote so you have a string. This is I, this is j. So you want to check if this whole string is a palindrome. How you would do that is, first of all, S set I should match S set j. So these two characters match, and you need to be sure that any substring in between is also a palindrome. So this or and sorry, these two characters match, and LPS of I plus 1 and j minus 1 equal to true, denoting it is a palindrome, right? So for this, you can just start at I equal to m minus 1, I greater than 0, I minus minus, and j from 0 to m, right? Or sorry, I to m. and you check this. If it is, then you would put LPS of I j is true, or LPS of ij is true, and then if it is true, you would check the length of this, which will be j minus I plus 1, and you would store this into this array. So this is true, and LPS of Sij would become mm, j minus I plus 1, or sorry, I minus j plus 1, right? Similarly, sorry, not LPS of Ij, just I. So in the case of S, you're calculating length of the longest substring, which is a palindrome, starting at that index. So you would have LPS of I, LPS, and this is actually confusing me. Let me just rewrite what I'm saying. So first there'll be a DP. Okay. So you know DP of I comma I is 1. So uh, a single character is a like a palindrome, right? So in this case, you check if this is a 2D array. If DP of if S of I equal to S of J, and either J minus I is less than 2. So only two characters are there and they match. So that means they are palindrome, or dp of I plus 1 j minus 1 is a palindrome. So if this is true, in this case, you would say dp of I and j is true, and sorry, LPS of I is I minus j plus 1. Similarly, for LPS of t, what you would do the same thing on string t. But in that case, instead of writing LPS of I, you would return write LPS of j equal to something. So you want the string to end, like you want the ending index, the longest substring, which ends at certain index. So you just change these values. So now you have a solution. So let's try to code it. Okay. So what I'm gonna do is I'm just gonna uh, declare global arrays, so I don't have to keep passing them around. And I'm going to convert each string to an array. Okay, so let's start with the solution. So you have in m as length of s, n as length of p, and array 1 is s to char array, array 2 is t to char array. LPS of s, I'm gonna call a function called LPS array 1, LPS of t as array 2. And we need to differentiate between whether we want the length of string starting, length of longest substring start, which is palindrome, starting at an index or ending. So for that, I'm just going to send a true false value. So in this case, I would need the start index. And in this case, I would need the end index, right? And return solve. What did I say? So you need a start value. So to tell the state that you have started matching or not. Uh, to n minus 1. So this is S pause. This is T pause. So you're starting S pointer from the beginning of the string, T pointer from the end of the string, and then a start value saying you have started matching or not. So I'll code the um, DP function first. So you have S pointer, which I'm just gonna call S, and a start value, right? So forget about the base case right now. Let's start with uh, what can be the solution, like the recursive solution. So as we said, there could be three cases. One case being you haven't started and you move the left pointer, the S pointer, and keep the T pointer at the same place. Case two, same thing, but move the T pointer, decrement it. And case three, when there's a match, right? These are our three cases. So as we said, if start equal to 0, so you haven't started. So case one would be solve of you keep S at the same place, but decrement T, and you still haven't started matching. Case two is increment S, keep the T same, and start is still 0. Now, if array 1 S pointer matches array 2, so basically these are our strings now. There's char arrays. So T, if they match, then you have a case 3 where you increase the longest palindrome found till now with 2 because you match two characters, and you go into a state where S has moved forward, T has moved back, and you are still like you have started matching the string, right? Now, else if they so they did not match, but start was 1. What would happen in this case? In this case, you would return. Okay, we'll fill these LPS, S, and T arrays later, but as I said, you can't just return 0 in this case. So you have to return the longest palindromic substring contained in either of the strings, which is uh, maximum of LPS S of S, right? Or LPS T of T. We'll come back and fill these arrays later, and we'll cache these values because this is a recursive solution, so it won't be accepted. So this is our, and in the end, you can return maximum of case 1 and case 2 and case 3, right? So this is our recursive solution. Now let's write the base case. So we talked about this. What will the base case be? So we're saying if S has reached the end of the first string, the S pointer has reached the end of our character array, right? Or T has reached the starting, like it has reduced to -1. In this case, you'd write something like this. So now the two cases. If S has reached the end, that means you only have uh, T to take stuff from, right? So let's call it case 1 or case 4. So if S is still less than array 1 length, then case 4 is LPS of S pointer. If T is greater than, so you have more characters in T that you can process. In that case, case 4 is math max of case 4 and LPS of PT. And you return this case. So you have the base case. Now let's quickly memorize this or cache it somewhere. So I know I need three things. So the state depends on these three parameters. So S, T, and start. So I need a 3D DP. Okay. Now what will be the dimensions of this? It'll be so for S, which will be the length of S, you have M, right? This has the length of N. So T can move from 0 to N or N minus 1 to 0. So, and start can be either 0 or 1. Okay. So after the base case, you're just gonna check if DP of S, T, and start not null. You return DP S, T, start. So you've cached this. Now, before returning it, you again cache it. S, T, start. Similarly here, before returning, you cache it. So now you have the uh, DP solution of this. The only thing you need right now is find the LPS array. So again, it's very easy. So I've called it what? LPS. So private, you're returning an array, LPS. So you're uh, sending an array and something which tells you either you have to get this longest palindromic substring starting at each index or ending. So for S, it's forward. So that's the true value. So it'd be an integer array of length of the same size, right? Now there's a Boolean DP array, which will tell you whether this is a very classic problem where you have to see if given two indexes, like two values, you need to know whether substring starting at I and J is a palindrome, ending at J is a palindrome. So this is what we're gonna do. So you need to find DP of I plus 1 and J minus 1. So anything for ith value, everything bigger than that should be calculated. That's why we're starting it from n minus 1. And for j, you need to know j minus 1 value. For dpij, you're checking if dpi plus 1 and j minus 1 is a palindrome or not, right? So for j, you need the previous values calculated first. So we're incrementing j starting from I, right? So now the two cases, there's one check first if array of I equal to array of j and so now this and what does it mean? So we talked about this. DP of I plus 1 and j minus 1 should also be a palindrome. Also, if j minus I is less than 2, that means uh, the length of the string, it's either j is equal to I, which makes it a palindrome, or it was a length of size, it was a string of size 2, and both those characters match. So again, it's a palindrome. So for this and case, you need to check if j minus I is less than 2 or dpi plus 1 and j minus 1 is true. I think this is clear enough. And then if this condition satisfies, then this is also true. And now you need to check where you need to put that value. So if this was forward, that means I want to know longest palindromic substring starting at I. Or if this was case 2, which is for the string T, I want it ending at J. So we are for each case is processing for I and j, right? We know the length now, and we have checked if this is the palindrome or not. So for the forward true case, for S case, we know the length of the longest substring, which is the palindrome. Starting at I is j minus I plus 1, right? So LPS of S will include I in it. Otherwise, LPS of T will include J. So we need ending index. And LPS of index equal to maximum found so far, or J minus I plus 1. So I think this is it. And you return the LPS array. So I think we've covered everything. Let's try to run it. Yeah, so it does work. And it's a O of n square solution. Yeah, so that's pretty much it. Thank you.